Hello, everyone. One of the big visions of Apache Beam is to provide a unified programming model for batch and streaming that runs on multiple execution engines. And in this talk, what I'm going to show you is we'll explore an end-to-end example how you can actually run your Beam pipelines on different execution engines on AWS. So you will not only learn how you can leverage the expressive model of Beam, but you'll also learn how AWS can help you to run your Beam pipelines with low operational overhead. And I'm actually a big fan of building something live on stage instead of going through a set of slides. So the talk is very light on slides, and I'm spending most of my time in the AWS Management Console. So for that end, let's assume we're in charge of operating a taxi company in New York City, and we'd like to gather metrics from our cabs and analyze them in real time. So we'd like to build some kind of real-time dashboards that show us aggregations so that we can optimize our fleet. So how would you build something like that on AWS? As this is the Beam Summit, well, I guess the architecture looks something like this, right? So on the left-hand side, we have the producers that send data, which are kept, so geospatial data that is picked up by a Beam pipeline, aggregated, and then sent off for visualization. So first of all, we need to find something that can run our Beam pipeline. I'll start with using a service called Amazon Kinesis Data Analytics for Java. And although you may not get it from the name, this is actually a managed Flink offering. So what the service does is allows you to give us a jar file, and we will execute the jar file on your behalf. So we'll provision the infrastructure that is required to run Flink. We'll deploy your jar file, your Flink file. We will monitor the health of the different nodes. If a node fails, we'll detect that, replace the nodes, and the service also takes care of taking checkpoints and save points, and it will scale the program, the Flink program, according to your needs, right? So to run Beam on AWS, what I'm going to do is essentially I'll use a Beam pipeline with a Flink runner that is running on Kinesis Data Analytics for Java. Right. Okay, so the taxi trips are not sending the data directly to the Beam pipeline. They're ingesting data into a service called Kinesis Data Analytics, which is basically just a replayable ordered log. So the taxis ingest the data into Kinesis Data Analytics, and the Beam pipeline will read the data from there, aggregate it, and then send it to CloudWatch, which is a service to collect metrics and log files and visualize them. So this works really well up until the point where you want to backfill your state or where you want to recompute KPIs over a large period of time. Because Kinesis Data Analytics provides a data retention of 1 day by default, which can be extended to up to 7 days, right? So if you want to run large backfill jobs or large reprocessings, that's not going to work. So in order to work around that, what I'm going to do is, in addition to the real-time path in my pipeline, I will ingest data from the Kinesis stream to S3, and I'm using a service that's called Amazon Kinesis Data Firehose. And what the service does is basically, it's a consumer of the Kinesis stream. It reads all the events from that stream, buffers them, and then sends objects to S3, where I can then read them with the very same Beam pipeline, but this time not deployed to a real-time environment, but running on Amazon EMR, which is a managed Hadoop service. So at this point, you may ask, well, why don't you use Kafka instead, right? So if I'm having trouble with the retention of 7 days, why don't I use Kafka? Because it supports like basically infinite retention. And you're right. However, I still think that this kind of architecture is valuable even if you're using Kafka. And the reason is, if you're running these heavy calculations, you're processing your entire history of data that's stored in your streaming store, it may easily overload your Kafka cluster and affecting your real-time portion of the pipeline. So it's basically about having different access patterns for your data. In the first case, you are looking for low latency so that you can populate your real-time dashboards. In the second case, you're looking at high throughput so that you can quickly backfill your data and you're not affecting your low latency pipeline. Right? So at the end of the day, it's just a way of using the right tool for the right job, using a streaming store for low latency read requests and a blob store for high throughput reads that can be parallelized quite easily. And in contrast to a Lambda architecture, as I'm using Beam, I can actually use the very same Beam program for batch and streaming. Right? I don't need to change the program. I can just change the source, and then I can use the very same program in batch mode, but also in streaming mode. Okay, so let's go ahead and actually build this architecture out. So for that, how that works. For that, I'm now going to change to the management console, and I'll start with creating a Kinesis data stream. So I'll go to the Kinesis console and create a data stream, which is again just a replayable ordered log. Every stream has a name. We'll call this Beam Summit. And each Kinesis stream is composed of shards. And adding and removing shards is a way to scale the throughput of a stream. So every shard can ingest 1 megabyte of data and 1,000 records per second, and you can read up to 2 megabytes of data from every shard. And by adding shards, you can scale out your stream. And for this example, I'm ingesting like 2,000 to 3,000 events per second, so 4 shards is going to be enough. And now I'm creating the stream. So now in the background, we'll provision the infrastructure that is required to have 4 shards that I can write data to. While that is going on, I can already create the Firehose delivery stream. So up until now, producers, taxis can ingest event data into the Kinesis stream. And what I'm doing now, I add a Firehose delivery stream to redirect this data onto S3, which is a blob store, so that I can query the data or read the data for my high throughput case later on. So I will just connect the Firehose delivery stream to the Kinesis stream, which essentially means I need to create a Firehose delivery stream. Every stream has a name, so I'll call this Beam Summit as well. And I'll point it to the data stream I've just created. In addition to just dumping data from a streaming source to a destination, Kinesis Firehose also allows you to do processing on the data. So what it allows you to do is you can specify a Lambda function, which is basically just some code that you give us, and we can transform and enrich events that are sent from Firehose to S3. And I'm actually going to use this to tamper with the events, and I'll explain later on what I'm actually doing here. So I'll choose a Lambda function I've already provisioned, but I'll share the sources so that you can see what's actually going on. So for now, just affect the fact that I'm tampering with the payload of the events. In addition to just dumping the data, you can also convert the data into Parquet while you're ingesting it into S3. I'm not going to use this for the demo, but that's quite convenient if you want to just ingest streaming data into a data lake. You can convert it on the fly into Parquet while you're ingesting it, which is pretty nice. Firehose does not only support S3 as a destination, it also supports Amazon Redshift, which is our data warehouse, Elasticsearch service, and Splunk. But for now, I'm just going to use S3. Okay, so now I basically need to specify the destination, so I've already created a bucket. There you go. And I'm going to use that, and I can specify a prefix. Just to get this right, I'll look it up, Kinesis data stream data. And in addition to specifying a static prefix, you can also specify how the data should be partitioned according to the date of the events that have been ingested into the Kinesis stream. So I'm not using that right now, but that's an option you have you can partition the data in a custom way by specifying the partitioning right here. Yeah. So now I need to configure the buffer conditions, which basically means Firehose will buffer events so that you can flush large objects to S3. Similar to HDFS, you don't want to have very many small objects on S3. S3 works best if you have fewer larger objects. So with Firehose, you can buffer those. And in general, it's a good idea to increase these values. But for the demo, I'm interested in getting results fast, so I'm misusing that and setting that as low as possible. You can also encrypt the data, so instead of just dumping the raw events, you can convert them to gzip, snappy, and zip. Yeah, and a couple of other options that I'm not going into right now. Last but not least, I need to give the service access to my account so that the Firehose service can read from my Kinesis stream and write to my S3 bucket. So I'll just quickly pop over to the identity and access management to authorize the service to make those calls on my behalf. And that's basically it. So I get to review the decisions, and now I've created the Firehose delivery stream, right? And that's all it takes. So again, now we are provisioning infrastructure under the hood that reads from S3, that reads from Kinesis and outputs blobs to S3. Last but not least, I need to create the Kinesis data analytics for Java application to actually run my Beam pipeline, right? So I will create an application, and you guessed the name is Beam Summit. And there are two different flavors of Kinesis analytics. One is an SQL runtime that allows you to just write SQL queries and run them against a stream. And the second one I'm going to use now is the Apache Flink runtime, which is currently at the version of 1.6. So again, the service needs permissions to read from my stream and write to my CloudWatch dashboard. So I'll associate a role that gives the service full access to my account. And I hit create application. So now the application is created. I just need to configure it a bit more to tell it where the jar file is located and things like that. So I'll hit configure. And I've already compiled the Beam application and stored the jar file on S3. So I'm just going to point Kinesis Data Analytics there. So I guess it's this one. And I'm using a path to the object. So this is just a location on S3 that holds my jar file. And I can then pass parameters to my Flink application or to my Beam application, right? Usually, you would just pass those parameters when you're invoking the Flink program. However, this is a managed service, so you don't get access to the Flink cluster. So you need to use this kind of mechanism to pass your parameters into the program during runtime. So I'll just add a property group, which is basically a collection of key values that are then exposed to the Beam pipeline during runtime. So I basically just pass in the stream name, and I've called the stream Beam Summit. So now the Beam application knows where to read the data from. Kinesis Analytics also takes care of taking snapshots and save points. For now, I don't need that for the demo, but that's very convenient if you're running in production. You have a high interest that your Flink program can recover, and by enabling snapshots, that's what the service does on your behalf for you, right? So I'll update the pipeline, I'll update the Kinesis Analytics application, which basically means the service now reads the jar file, adds the configuration parameters into a Kinesis Analytics application, Kinesis Data Analytics for Java application. Okay. That takes a moment, and once it's complete, I can now start the execution of my program. Right. So I'll hit run, and this now deploys the jar file in Flink on a managed Kubernetes cluster. Okay. While that is booting up, which takes like a minute or two, I'll already start ingesting events into the Kinesis stream. And for that, I've already provisioned an EC2 instance, and I'll use a jar file to replay a historic data set of taxi trips into the Kinesis stream. So I'll connect to the right instance, and then download the jar file, and I can finally execute it. And again, all this does is basically it reads a historic data set of taxi trips that were made in New York City from S3 and replays that as individual events into the Kinesis stream. So now if we are lucky, the application is already running. It is not, so it takes, as I've mentioned, 1 to 2 minutes until it's there. And once it is running, we can inspect the operator graph of Flink in the console and then head over to the outputs. Cool. So as we're waiting for the application to come up, I'll already start creating the dashboards, because what is happening now is I'm ingesting events into the Kinesis data stream. The Beam pipeline is reading that data, aggregating it, and sending the results to CloudWatch. And I'm now going to build a CloudWatch dashboard to actually visualize the data that has been generated by the Beam pipeline. So I'll head over to CloudWatch and select the metrics. So basically, it's a custom metrics that Beam is emitting to CloudWatch. And if I pick the right settings, there we go, I can create a dashboard. That holds the data. So there you go. So if you wait 1 more minute or so, we'll see these regular patterns that you would expect. So basically what this metric shows is the number of trips that have been started in a given interval. So I'm using a 5-second tumbling window to aggregate the taxi trips that are made in New York City at that time. So and you can see that data is arriving more or less in real time as we talk. Cool. So that worked out pretty nice, and I'm now going to change the requirements as it usually happens in these projects, right? So now instead of counting the trips that are made in New York City, I want to break that down into boroughs. And I'm really short on time, so I've already baked that into the code. So I'm just setting a flag so that instead of outputting the global count of taxi trips in New York City, I'll output per borough counts of taxi trips to CloudWatch. So I'll reconfigure my application. I'll just add another input parameter, which is just a flag to tell the program to actually output this different data. So I set output boroughs to true and hit update. And now the program is redeployed. And once that's up and running again, we should see the metrics arriving at CloudWatch. Right? However, that only holds true for new metrics, right? So the moment the program starts, we'll receive metrics on boroughs from that point in time. So what I'm now doing is I want to backfill the history of events that has been offloaded to S3. And to that end, I'm going to use Amazon EMR, which is a managed Hadoop offering. I've already created a cluster in my account, so now I'm going to log into the cluster, read the historic data from S3, and populate my CloudWatch dashboard to show you how that would work. So let's connect to the cluster. When you create an EMR cluster, you can choose to bootstrap Flink onto the cluster already, so that's what I actually did. So I didn't run any custom script. I just asked the service to prepare my cluster with Flink. So I can just start the Flink runtime, and once that's up and running, I can deploy my program, so the very same program that's running in Kinesis Data Analytics to the cluster running on EMR in a batch fashion. So I'm going to download the program. And once that's done, I can execute the program on Flink running on EMR in a yarn environment. So that's up and running, so we can now go to the EMR console and navigate to the Flink dashboard, so we can connect to the resource manager, and then from there go to the application master and Flink, and we can see that the Flink program is already running and reading data from S3. And again, what I'd like to point out here is I've provisioned a stream with 4 shards, so I can read up to 8 megabytes per second from that very stream. However, in this example, I've been reading, or at least sending, more than 200 megabytes in 7 seconds. So there's orders of magnitudes of more throughput when I'm reading from S3 rather than reading from Kinesis. So that worked out quite well. So when we go back to CloudWatch, we can add another widget to our dashboard showing the data per borough. So it's, again, another custom metric. I'll just select the right one. Oops, that's not what I wanted. Had to search. There you go. So if we now take a look, we can see, okay, it actually worked. So this is the data we've seen previously while the old program was running, and we've successfully backfilled the historic data with the new output we'd like to generate. And when I update the visualization, you can see that now the program, the Flink program or the Beam pipeline is actually running and providing new data for new outputs. Okay, cool. So that concludes the demo, and I'll quickly wrap up. So a couple of best practices and lessons learned that I learned while I was building this demo. First of all, how did I achieve the same semantics for the streaming and the batch case? Because in order to get the same semantics, I cannot use processing time, right? So actually what I did is, when you ingest data into a Kinesis stream, a timestamp is added, and this timestamp is used by the Kinesis connector as processing time. So what I did with the Lambda function is actually adding this timestamp into the data so that I have the same timestamps both in the stream and in S3, and I can then set the timestamp accordingly when I'm reading the data from S3, right? So in this way, I get the exactly same semantics for both batch and streaming. What does it actually take to run a Beam pipeline or a Flink program on Kinesis Data Analytics for Java? Well, basically, as it is based on Flink 1.6, you just need to add 2 dependencies. One is the Beam runner for Flink 1.6, and then there's an additional dependency so that the service can actually communicate with the Flink program itself and pass in those parameters. If you ever have worked with Flink, you know that it can be a pain to actually deploy your program on a cluster, right? Because of problems with dependencies. So usually this ends up with you develop your program locally, it works, you push it to a cluster and everything breaks, and because you have some kind of conflicting dependencies between your local environment and your cluster, so you'll likely end up shading some dependencies, and this is what worked for me. Your mileage may vary, but with these shadings I was able to get the program running locally on EMR and on Kinesis Data Analytics for Java. This just shows how you can obtain the parameters that I have specified for the Kinesis Data Analytics program during runtime. So you basically just call a function to get the application properties, select the right property group, and then can iterate through the key value pairs. So this is how you can communicate parameters to your Flink program. And last but not least, the Kinesis source makes it very easy to use static credentials to authenticate against Kinesis. However, it's a best practice to use temporary credentials, and by associated permissions to the Flink application, I'm actually able to surface those temporary credentials during runtime. And if you're just using this, the Flink program will pick them up so that you don't need to store static credentials in your code. And last but not least, if you're looking for more information how you can run Flink on AWS or Beam on AWS, I recommend subscribing to the AWS Big Data blog. There are a couple of blog posts on Flink on AWS already out there. And if you want to understand what I did during the demo, I've published the source code under this GitHub repository, so you can go there and figure out the details of what I have been doing all this time. Cool. So we've seen how you can operate Beam pipelines with low operational overhead in a fully managed, scalable, and highly available environment. So I'm really curious to see what you're going to build if you can focus on writing your Beam pipelines rather than operating them. And with that, I'm opening it up for questions. Thank you.
Thank you, Stefan. We have time for one question, so anyone has a burning question that would like to ask Stefan? Here we go.
Yes, thank you for the talk. It's very interesting and actually exciting to see Flink running on AWS and Beam pipelines. I'm not sure why it's called Kinesis Analytics, though. I think if it would be called Beam or Flink, then more users might try it in the future. What I wanted to ask is, which connectors are you using to read the data of both Kinesis and S3? Mm-hmm.
So I'm using the standard connectors that come with Beam, right? So though the Kinesis I/O and the text I/O, I guess it's called, and I'm pointing that to S3.
And what modifications did you have to make to the Beam runner to run in the AWS environment?
Basically just including those two dependencies for the Flink runner and the Kinesis Analytics dependency, and then shading the dependencies. So that's basically all it took. So it's very lightweight, just adding dependency to your project and then deploying the jar file.
Okay. Awesome. And this is running on Yarn or on Kubernetes?
This is running on Kubernetes. So yeah.
Okay, great. Thank you.
Yeah, you're welcome. Thank you.
Thank you, Stefan.